Now let's do the third experiment, which is basically we have to verify the series or parallel combination of resistors using meter bridge again. So the theory and the principle formula, everything will remain the same. So I have to first make a tabular column for finding R1 and R2 separately. Basically we will be given two unknown resistors. You have to before connecting them in series, you have to connect them individually separately and find out how much it is using the first method. So basically I have connected here only R1 now. I was given two resistors R1 and R2. I connected only R1, just like here. I connected, instead of X, I connected only R1 and I found out how much it is. It was 1.06 ohms. Similarly, I connected only R2 and it was also 1.06 ohms. Now I have connected in series. So how to connect in series? Basically you keep the two unknown resistance like this. So in the gap 2, one wire should come and attach it to the first terminal, and then from the other terminal it goes here, and then from this terminal back to this terminal. So that's how you connect for series connection. Now this is in series connection. The connections is same as the previous experiment. So from battery positive to A, battery negative to B, then across this gap I have connected resistance box, that is a known resistance. Across this gap I have connected unknown resistance in series, first individually and then in series. So from here to galvanometer and the other end of galvanometer to jockey. Now I have already taken the readings. So when I have taken, this is the reading, when I have taken out 2 ohms, so the balancing length was around 46 centimeter, and I've calculated the series resistance, which is around 2.3 ohms and 2.2 ohms. So this is the actual value. If I consider 1.06 and 1.06 as the actual value, the series resistance I should have got is 2.12 ohms. What I'm getting now is 2.25 ohms. So the error is 6.1%. So which is almost same as the previous experiment. Also we got 6%. So it's almost it is maintaining the same error. Now there could be ways to decrease the error. We'll discuss about that. So to improve the error, what we can do is, so we have to just get a gist of what could be the internal resistance. So everything all the keys will be plugged in and it will be tied, and I'll just check at which point on the scale I'm getting a zero deflection. So you can see that the zero deflection is occurring at about 2 centimeter here. So what I'll consider 2 centimeter as my new zero. So basically whatever I'll get here after pulling out the key, whatever I'll get, I'll add 2 centimeter, because 2 centimeter is my zero now. Now 2 centimeter actually is taken by the internal resistance of the box. So around here is my actual zero. So now what I'll do, I'll take out 2 ohms. I'll make sure everything is tight, and then again I'll see at which point I'm getting the zero deflection. So I got again at 46 centimeters as before. Basically now I have to add 2 centimeters because I've started, my reference point is 2 centimeters. So basically I'll get 48 centimeters, and you can see that results in an improved result. So earlier I got 2.3 ohms, so 46, I just added 2 here, so 48, so the result is 2.16 ohm, which is better. Now similarly I have added 2 centimeter for the previous reading, so I had got for 3 ohms 57.5. so my new L value would be 59.5 because I just added 2 centimeter to 57.5. now you can see that the result is 2.04 ohms. So my average would be 2.1 ohms. That's my experimental value. So the actual value, like before, it was 2.12 ohms. So you can see that my error has improved a lot. So it's 0.2 divided by 2.12 into 100. So that's my error. So 0.2 divided by 2.12 into 100. So my error is something. Okay, it's coming 9.4. Sorry, I made a mistake here. It's not 0.2, it's 0.02. So So obviously this error is very much less than 6%. So that's how you can improve, that's how you can account for the error which is being caused by the internal resistance of the resistance box. So now let's start with the experiment of using the meter bridge to verify parallel connection. Again, the theory is same. This part of the theory will be same. For parallel connection, this would be your observation table. So again, you have to find R1 and R2 individually, just like we had done here. And for 1 by R1 plus 1 by R2 inverse of that, we are trying to find the reading. So for the first reading, I have taken out 1 ohms. So balancing length was 67.2 and the 100 minus L is 32.8. I got 0.49 ohms. Basically, if I consider 1.06 and 1.06, I should get around 0.52 ohms. So I'm getting 0.49 ohms, which is okay. For the next reading, I will be taking out 2 ohms. Again, the connection is same as before, just like in series. The only difference is the parallel connection has been made now. So here across this resistance box and across this unknown resistance, you have to keep it like this. 2 resistors, unknown resistance. If you want to connect in parallel, you have to keep it like this, and then from here to this terminal, and from the same terminal to the other end of the other resistor. So from here to this end, and from the same end to this one. So basically, parallel connection means from the same terminal there will be at least 2 connections. So in the series there will be only 1 connection from 1 terminal. So that's how you remember it. So now for 2 ohms, you can see that the 0 is occurring at around 78.6 centimeter. So for I've taken out 2 ohms and it's 76 centimeter. Okay, I forgot. Let me check again. So it's around 78.5 centimeter. Okay, so it's 78.5 centimeter. So 100 minus 78.5 would be 21.5, and my x will be now 2 into 21.5 divided by 70, 2 into 21.5 divided by 78.5. Remember that in the exam you can't use the calculator. For now I'm using it. So I got 0.54 ohms. So if I make the calculations and my average experimental value would be 0.52 ohms, and the actual value, considering that each resistor is 1.06 ohms, so the parallel combination yields 0.53 ohms. So the error is actually less than 2%. So one thing you have to remember is that for parallel connection, error will be slightly less when compared to series connection.